This is Quickener's tutorial. In order to help you to prepare for this your upcoming exam, very quickly, one of the frequent questions you are going to see in your physics exam will be coming from electricity, okay? So electricity, alright, is of two types. Mm? We have current electricity and static electricity. So I've discussed static electricity in our previous class. So you can just check my page on the YouTube. Static electricity when we talk about loading electroscope and all that. Okay. So now when we look at current electricity, the first is that electricity lays the flow of charge. Alright? That is the study of what? The flow of current from one point to the other. You understand me? So the most important person in current electricity is ohms. Ohms. Alright? That gives us Ohm's law. Alright? That gives us what? Ohm's law. Ohm's law is the most important law. And then you can remember your V equal to IR. Right? Good. So let's look at that Ohm's law again. You see, Ohm's law is very, very significant. Why? Because Ohm's law is majorly concerned with metallic conductors. Please understand me. Metallic conductor. So let's assume we have a metallic conductor. Alright? This is a metallic conductor. All metallic conductors, most of them are in cylindrical form. You understand? Cylinder. Tiny cylinder, elongated. You understand me? So what does Ohms say? Ohms now said, let's assume that this is our current flowing this way. You know, in our previous class, we said that if electron is flowing that way, current will be flowing this way. So electron and current are moving in opposite direction. So let's assume that this is our current. Ohm said that the current that will be flowing through this metallic conductor, that is to say wire, alright, either copper wire, aluminum wire, and all the kind of wires that we have today. The current that will be flowing through this wire is directly proportional to the PV across the two ends. What is PV? PV is just the potential that will be set. You know, when you say potential is just to set a tendency to move from one point to another by means of concentration, okay? For instance, now, the potential we're talking about here is that the charge is moving from where it is more to where it is less. You understand me? From the cell to the other part of the circuit. You understand what I'm saying now? So, the focus is that the current flowing through a metallic conductor is directly proportional to the potential difference set across the two ends. And the conditions are temperature is constant and other physical factors remain constant. So that gives us two ways of discussing this current electricity. So we have current electricity 1, 2, and even 3. Okay, let's just do the first one. The very first one is that we want to focus on the Ohm's law, the conditions of the Ohm's law. So now, this helps us to establish a formula. And that formula is that you can put it the other way. That is voltage is directly proportional to current, and what is constant is what? Resistance. Okay? So all the other conditions that we talk about, temperature, the other physical conditions like the length of this wire, the cross-sectional area, you can see, is a cylinder, so it has a cross-sectional area. The cross-sectional area and the nature of the material, they all affect resistance. So if they are constant, that means that resistance is a factor that is constant there. I think that's a very simple way to understand it, at least at this level. The resistance of a metallic conductor is directly proportional to the length and inversely proportional to the cross-sectional area. So the condition for it The constant of proportionality is what we call resistivity. Alright? So that gives us a very beautiful formula like this. You can see. A very good formula that we might use for our calculations. Now, we said in Ohm's law, the current flowing through a metallic conductor is directly proportional to the potential difference, provided that what temperature and all other physical factors remain constant. These are the physical factors we are talking about: the length, the area, and the nature of the material, which is factored in this resistivity. Now, I want to discuss this resistivity. Resistivity simply means the amount of resistance that a material will offer to the flow of current. So the opposite or reciprocal of resistivity is conductivity. So when a material is highly resistive or resistant, the conductivity is very, very low, and vice versa. So for metallic conductors, their resistors are very, very low, and their conductivities are very, very high. Now, why the non-conductors, which are also called insulators, their resistors are very, very high, and their conductivities are very, very low. This is to say that every material has a measure of resistance and conductivity. You understand me now? So the ones that have high conductivity and low resistivity are conductors. I think you understand that now. So let's look at examples of highly resistive materials. So some materials are actually used for, creating a resistor, either the standard resistor or the what do you call it? Variable resistor. So those materials are like mica wire, constantan wire, you understand? Tungsten, some of these materials they have very high resistance, okay? I get it. But there are some materials that do not conduct at all. That is, they have infinite resistance, like your plastic, your rubber, your firewood, all the stuff that do not conduct material, paper. They have infinite resistance, that is, they will never allow the conducting of electricity. There are some materials that at a very high voltage, their resistance will be broken, they will conduct electricity. For instance, air, or let me say, gas. Gas does that at a very high voltage and a very low pressure, they conduct electricity. But we're talking of some materials that are used as insulators at a voltage of about 20,000 plus or more than they conduct electricity. So you have to be very careful. If you watch all these videos, you see how electricity, high voltage, high caution is taken when working in all these high voltage, plant. I know you know what I'm talking about. But let's go back to what we're discussing. Now, the materials that are very, very conductive, you understand? Conductive, we want to talk about conductivity now. So, like I said resistivity is inversely proportional to conductivity. So, the materials that have high conductivity are silver. Silver is the most conductive metal, by the way. Then you now have copper and down to aluminum. Okay? So, now, the materials that are used in transmitting our national grid from the point of production to where we are a mixture of all these metals, this alloy, in order to improve because the truth is that when we have a very good material to transport our electricity, the cost of transporting it is very low. That's to say that when moving electricity from where they are produced to where they are consumed, there is loss in the national grid energy or power. You understand? Because of heat and the nature of the material. So if we have more efficient material, we're able to carry a very maximum amount of this current or voltage from where they are produced to where they are consumed. Or power. Let me use the word power. Do you understand what I'm saying now? Okay. So now you can see how beautiful this formula is. So that means that if I make resistivity subject of the formula, I'm going to have something like this. Resistivity equal to cross multiply, that is AR, then divided by N. So in this case where we have resistivity as reciprocal of conductivity, hmm, it means that conductivity using the same formula, we're going to have it in this way. Then over what? A times R. Can you see that now? So that's just one aspect. Hmm? So let's talk about how temperature affects resistance. Increase in temperature affects the conductivity of metal. That is, you reduce those conductivity. You understand me? That is, it increases the resistance. Alright? Are you getting me now? So temperature has a very, very negative coefficient to what? Conductivity. You understand me? So now, the length of the material, the longer the material, from what you can see here, the longer the material, alright, the more the resistivity or the lesser the conductivity. That is, if the wire is longer, if the length is longer, the ability to conduct electricity reduce. That is, the resistance increase. You must understand this word. They are vice versa. You understand me? Alright? So how does processional area affect? Because in processional area, the more the area, the more the amount of current that will flow. You understand me? So the more the area, the lower the resistance or the higher the conductivity. I think you understand some of the things that I've shared so far concerning this this aspect of electricity. Okay. Now another thing you must know is that we have what we call circuits. We have what we call circuit. Alright? Circuit is simply a path provided for the flow of current. I get to it. Current has to go and return. That's why you only have two wire. You understand me? They have to be flowing and returning. So in most cases, the red wire is what is making the current, and the black one is taking back the current. It's not always red or black. There are different colors, but most times it's red and black. So now, circuit, we have what we call open circuit and closed circuit. So we usually use our key. This is a plug key. That's a plug. This is what we call plug key. So a plug key is something like this. Alright? Plug key like this. You plug in something in a metallic conductor to close the circuit. Okay? Then we have what we call tap key. So you can see tap key is something like this. Alright, this is called tap key. So these are symbols of all these things in a what? In a circuit diagram. So let me give you a simple circuit diagram. So the circuit diagram we have a cell or battery. Battery means when we have two cells and more. If you don't have one cell like this, it's called a cell. You don't call it battery. So when you now have additional one like this, when you have additional one like this, that is now a battery. You understand me now? So it means that that car battery you call a battery has multiple cells. In many cases they have 9 cells or 12 cells. Are you getting me now? Why do we put cells like that? So that we can combine the voltage and have a very high voltage. So in a electric cell that produces about 1.5 voltage, if you have that cells in 6 of those cells in a serial arrangement, that means 6 times 1.5. What would that give you? That would give you what? 9, right? 9. So now this is a cell. So let's put our key here, our plug key here. We have a plug key here. We have an ammeter. What does ammeter do? Ammeter reads the amount of current that is flowing. Okay? Then we now have our load. We have our what? Load. This is not a sign for load, but it's a sign for resistance, okay? But I call it load. I call it load because most loads have amount of resistance. So this is our resistance. Are you getting it? Then we now have our what? Voltmeter. The voltmeter Look at, mind the way I connect the voltmeter. The voltmeter is always connected in parallel to a circuit because it has a very large amount of resistance. Very large amount of resistance. If you connect it in parallel like the way we connect this ammeter, the current might not flow because it will resist the current. Take note. Now, there are types of resistance that we're going to look at. We're coming back to that. Let's just discuss circuit. So, if I put a dot here, I have closed the circuit. Remember, this is a plug in. Alright? If there's no dot here, the circuit is still open. That gives us two types of circuit. Open circuit and closed circuit. So, what is an open circuit? An open circuit is, the one that current does not flow because it's open. Once the circuit is open, current will not flow. Simple as that. But a closed circuit, just like this. No. Once you connect the wire, just like connect the wire and allow the current to flow. You understand what I'm saying? A closed circuit is the one that allows the flow of current. Now, look at this cell. Can you see that this cell, this longer side is the positive side? And this shorter side is the negative side. Okay? So this cell is connected in series. Alright? And in series connection, if this is 1.5, the other one is also 1.5, the total potential difference that will be gotten from this cell will be what? 1.5 plus 1.5, that is 3.5. I think you understand that, right? Now, that is the total what? Total potential difference or electromotive force. Talking about electromotive force, you can see electromotive force is the generator of the flow of energy. Alright, that's the generator, the one producing the energy. Alright, so electromotive force is the work done required to move a positive charge from one point to another. Usually from the point of high concentration to the point of lower concentration. It is directly connected to potential difference because potential difference is the same thing as electromotive force. So when we say potential difference, we are talking about between two terminals. Okay, so from here to here, potential difference. But when you are not talking of the potential difference between the terminals of the cell or the battery, that is what we now call electromotive force. You can see they are the same thing, right? So what is now PD? PD means potential difference. Alright? So what is voltage? Voltage is simply the unit for potential difference. That's the unit for potential difference. We measure potential difference by voltage. So when you say voltage is the work done, the moving charge round a circuit, it's still the same thing. The terminal PD is the PD across two ends. Terminal. That word terminal. So okay, this is terminal PD. And that is the terminal PD. When the PD runs through the circuit, the terminal, just across two ends. So when we take the measurement, that will be the terminal PD. Whatever we take here, that will be the terminal PD. You understand what the measurement at this point. Now, what do we expect? Remember that the PD from the generator itself, which is the cell on the battery, is 3.0 volts. By the time it moves around and come here, the PD is going to drop. And that's a very significant point you must understand. There's a drop in PD. Why? Because this cell itself is also made up of material. And earlier we have said that every material has a measure of resistance. Okay? So because of the material that this cell is made up of, it has resistance. So that gives birth to what we call internal resistance. Okay? Internal resistance, small letter R. So this one is the bigger R, the resistance from the load, and the internal resistance is the resistance from what? From the cell. You understand me now? So the PD of 3.0 might end up reading here as 2.7. So there's a loss of what? 0.3. I'm just assuming. That loss is as a result of internal PD. Are you getting it? That will now help us to have the ultimate formula for this whole calculation. What's the ultimate formula? The ultimate formula is that the total energy or potential difference, which is EMF, electromotive force, is equal to the terminal PD plus the loss PD. Like I said, energy will drop. There will be a loss in energy or PD. eh, after the whole cycling. I don't know if you understand. You can see that now, right? Okay, so the electromotive force, like I said earlier, is equal to what? The terminal PE plus the loss PE. Take note of all these words I've used now. So the capital letter is what? Terminal PE. I hope you can see that. Terminal PE. Then small letter is what? Loss PE. Eh? Then this one is the total energy. You already understand what this formula is made up of, right? So let's break it down. So we have EMF, which is always used as E, which is always used to represent it, is equal to this terminal PE is the resistance times the current. Remember, V is equal to IR. We have established that, right? V is equal to IR. So the current and the linear resistance plus the loss PE is the same current and the solar resistance. Why do they have the same current and different resistance? This one you already know. This is the voltage across the terminals of the whole setup. While this one is the voltage that is lost, or the energy that is lost as a result of internal resistance. The current flowing is the same. It is a series connection. You can see the current flow from here and it comes to this place. So it is the same current that passes through the cell and the same current that passes through this external load. You understand that? So that is why they are using the same current. So when you factorize that, it means that R plus small letter R. Can you see that? So E is equal to R plus small letter R. So that helps you to be able to determine your current. Let's assume we are looking for current. It means that the formula for our current would have been what? The EMF over what? R plus small letter R. When you divide both sides by R plus small letter R, you get that. I want to talk about the resistor. We have two types of resistor. Fixed resistor or standard resistor and variable resistor. So what is a standard resistor? The standard resistor is the one you have, you just write the amount. 5 ohms. It cannot be adjusted. 1 ohms. It cannot be adjusted. Alright? So this is the representation of a resistor in our circuit diagram. All of them have representation and I'm giving you most of them. So each or these represent our resistor in our circuit diagram. I hope you understand. So what is a standard resistor? I said once you see a resistor with a fixed amount, these are 1 ohms, 2 ohms, 3 ohms, 5 ohms, they are all standard resistors. Are you getting me? They are fixed. Then a variable resistor, there are two types of variable resistors that we often use, or the common variable resistor. The word variable means you can change the value of the resistance. Are you getting me now? So we have a rheostat. What is the symbol for a rheostat? Alright, I want to put up the diagram where you can see it clearly. So a rheostat is something like this. This is a rheostat. Can you see? Rheostat. This is the word. Rheostat. You know a rheostat now. Some of you know this rheostat, okay? Now, that's the symbol for a rheostat. What you see is a variable resistor. It means that the resistance can be adjusted to any value that you want, depending on the practical you are carrying out at that point, or what you need. Now, we also have what we call resistance bus. So, a resistance bus is something of this manner. So, we have different resistors and the amount of, plug in that we plug, we calculate, the total resistance we are making use of. We have, remember, resistance bus and the rheostat. They are all examples of variable resistors. Thank you very much. Thank you as we solve more questions on this topic.